Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching one of the most exciting series, Zero to Hero series on ESP32 development board, ESP32 CAM and ESP8266. We haven't started the camera portion of it, but in the next few lessons I'm going to start building some projects and show it to you how to use the camera aspects. For now, we will continue with ESP32. Alright guys, so let's get started. In this lesson, I will show you how to display temperature and humidity reading from DHT11 sensor or DHT22. There are two types of sensor. Well, actually there are many humidity and temperature sensors in the market, but the most optimized and the most I would say low cost, easy to use are DHT11 and DHT22 sensor. In this lesson, we will plug into SSD1306 OLED display. I hope you guys have it. In last couple of lessons, I showed you how to download the library for SSD1306 OLED display. So in this particular lesson, we will be using the ESP32 with C++ coding in Arduino IDE. We can also convert this into Thonny by using MicroPython code in the Thonny IDE as well. So whichever the exercise I am showing it to you using Arduino, that is on C++, and the same thing can be converted into the MicroPython code as well. Of course, there will be bunch of changes in terms of the syntaxes and the calling the functions and stuff like that, but the logic and the rest of the functions remains same, the libraries remain same. So in this particular lesson you need to install three important library. Number one, the SSD1306, which we did already in the previous lesson, right? I showed you how to install it. And also the combination library for SSD1306 OLED is GFX, that is for the graphics basically. So that's Adafruit underscore GFX. If you type, you will get that library. Go ahead and install it. And the other one is Adafruit underscore SSD1306. Go ahead and install. In the previous lessons, I clearly showed you how to install it. Go ahead and install. The most important library is DHT. So what you got to do, obviously, let me just open up a file and let me show you to you. So let me share my screen. Just give me a second. I hope you can see my screen. So go to sketch, include library, go to manage libraries. From manage libraries, just leave this box open for a few seconds till it gets refreshed, updated, and here on top in uppercase type DHT. If you type DHT in uppercase, within few seconds, what's happening? There's nothing is coming up. Okay, there you go. Dht Sensor Library, the third one, the first, second, and the third one. You need to scroll it down. By Adafruit, it's written as by Adafruit. Arduino sensor library for DHT11, DHT22, and temperature humidity sensor for libraries like DHT11 and DHT22. So go ahead and install. You might want to read the more info button. Click on that and open up the section. It's going to take you to the DHT sensor library, Adafruit's GitHub account. I highly recommend go ahead and read about the libraries, what kind of code it is, what it does, and stuff like that. Try to understand, guys. Do not blindly just download the library and do what I'm trying to do. So there are dependency packages for sensor driver, which is Adafruit Unified Sensor Driver, which we did install in a couple of lessons before. And then there are a lot of other things. So go ahead and read through these files, the CPP files and the header files and stuff like that. You will get an idea what exactly it is. All right, so once it is done, now let's see what we need to be doing. Just give me a minute. Right, now what we will do is, let me just walk you through what exactly this particular sensor is. So for example, The DHT1 sensor, right? So this is how it looks: DHT11, DHT22. So the white one here is the DHT22 sensor, and the blue one is a DHT11 sensor, right? So basically, DHT11 and DHT22 are very similar but differ in their specification. There are slight changes in the specification itself. The follow so I'll show you the table which compares. Basically, I'm going to show it to you in the next slide, some of the most important specification of DHT11 and DHT22 temperature and humidity sensor. So these sensors contain a chip, a small, like tiny little chip inside the blue or the white casing inside, that basically does the analog to digital conversion and split out the digital signal with the temperature and humidity within the environment, right? This makes them very easy to use with any kind of microcontroller, not just with ESP32, but you can use it with Arduino, Raspberry, any of the microcontrollers, right? In fact, I did couple of projects using Jetson Nano as well, so I'm going to show you how to do that in the later series. So DHT22 sensor has a better resolution compared to DHT11 and a wider temperature and humidity measurement range. That means it detects the wider, larger environment compared to DHT11. Slightly expensive, not much, couple of ₹100. And however, it is also bit, as I said, it's little bit expensive compared to DHT11, and you can only request readings within 2 seconds interval. Randomly it gets refreshed within 2 seconds. That's a fantastic part, right? However, on the other side, the DHT11 has a very small range, probably few centimeters away kind of thing, and it's less accurate. It's not that accurate. The DHT11 is pretty low cost, just about, I think, some 150 rupees, 150 rupees or something like that. It's pretty low cost. Obviously, it's just for experiments and kind of thing, but not on a real-time IoT application. If you want to build a good IoT, a real-time weather calculations and stuff like that, I suggest use DHT22 sensor, right? However, you can request sensor readings every second in DHT11 as well, but it's just because of its cost, it's pretty easy. Now, despite the difference, they also work in similar way, right? Both the sensors work in a similar way with the same library, same syntax in the C++ code, and you can use the same code to read the temperature and humidity. So you just need to select the code and the sensor type you are using, nothing else, That's how it is. So let's take a look at it from the connection point of view, how the sensors are connected. If you look at here, the pin configurations, that's how the DHT sensor have basically, especially the white one, DHT22, have 4 pins as shown in this particular figure, as you can see just behind me. However, if you get your DHT sensor in a breakout board, like a modular, like a socket, it comes as a module, right? It comes with only 3 pins and with an internal pull-up resistor on 2 pin, that you need to put a external resistor. So that's what we are going to do in this particular lesson. I will show it to you. So I will also, in this particular table, if you see the connection, the pin drawing, the DHT22, DHT11 pin out, basically when the sensor is facing towards you, you need to keep the sensor towards you, face towards you, and that's the pin configuration, right? The pin number starts at 1 from the left to the right, like that. So let's go ahead and hook up our circuit, guys. We need to have one 10K resistor because we are using DHT11, which is very low cost, and it may not be accurate. The data may not be accurate. The most important aspect of this particular lesson is we need to understand how to program it, how to connect your OLED, how to start reading the sensor information, and then in the next lesson, I will show you how to publish this information on the web browser, real time on the cloud itself. So that's the most important aspect. So this is the basic lesson. Go ahead and build this particular circuit, connect to your GPIO pin 22, which is your SCL serial clock, and then the SDA pin of both OLED and your DHT11 or DHT22 sensor. Both are in parallel connection. That's how it works. And the positive to positive, negative to negative. So remember, use 3.3 volt and the ground pin to ground. So that's the way the hookup is gonna be. Now what we got to do, we will just take a, not this one, probably, we will just go ahead and look at the code. What you can also do is you can download the code directly from my GitHub. I'm not going to explain to you line by line, because for that I'm arranging a one-on-one Zoom conference. There are many students who have already reached out to me, and I'm already conducting a one-on-one session in a group and a one-on-one as well. Group means it's a member of about 4 or 5 members, joining the call, and one-on-one is obviously me and you. So if you guys are interested to understand this in more detail, line by line, code by code, I'll be happy to conduct a one-on-one. Do reach out to me. So for now, let's go ahead and copy the code from my GitHub. So let me share my GitHub. Go to my GitHub account and go to ESP32 CAM section. In ESP32 and ESP32 CAM repository, in that you will find this particular code, DHT2 LED. Okay, DHT OLED. You can call it as 2 LED or OLED. Right? Click on that and go to raw. All right, Control A, and then right click, copy, and open up your IDE. Make sure that this is deleted, right? And then paste, Control V. And obviously once you paste it, what you need to do, do not forget to hold the boot button in your ESP32. Keep holding the button and then you click the upload button, right? And it will take probably about 15-20 seconds to upload, but make sure that do not release the boot button. It's very important. Keep holding the boot button, upload the code, is going to upload. So if you look at the code, it's we are importing the libraries, all the libraries which I mentioned to you, and then we are defining the pin, we are defining the height and width for the OLED display, and also we are declaring the pins, right? So in case if your display doesn't work, if it is blank, make sure that go back to one of my previous lessons to understand how to look at the I2C port, right? Which port it is picking it up. So you need to trigger that particular code which I showed you in a couple of lessons before, and from the serial monitor take this. It might be different, so copy that, put it here, so then it will work, right? Alright guys, so let's go ahead and upload. I have already uploaded this and I can see something blinking. Let me just show you my circuit. Okay, so I can see something is happening, but it's not reading the temperature. Why is it not reading? It says, but the good part is the OLED is working and I can see it's written as temperature none, and humidity no percentage, temperature no percentage. So that means there is some problem, but the problem cannot be with the code, because the code is working and I can see the sensor is blinking here. I can see a red light, but there could be some problem with the code or the wiring. I am not too sure. Let's try to debug. Sometimes guys, even the loose connection on the breadboard, it makes things little fizzy. All right, let's take a look at our serial monitor and see what is happening. Just give me a minute. Let's take a look at the serial monitor. Fail to read. Let me press the enable button, EN button. If I press enable button, okay, this looks like fail to read from DHT sensor. Alright guys, so that if we try to debug like this, the best part is the serial monitor, right? It clearly shows fail to read from DHT sensor. So what it means? This means that your circuit seems to be okay, because OLED is showing the display, right? OLED is showing the display. But on the serial monitor, it says fail to read from DHT sensor. That means there is some problem with the sensor itself. Your code is working, circuit is fine because OLED is working, right? So that means it's like there is some malfunctioning happening in your DHT sensor. So, obviously, boss, it's just 100 rupees sensor, so we cannot expect much. Sometimes it may work, it doesn't work. Or there are chances, based on my experience in the past, I left the circuit as it is, let it run, it'll say fail, fail. After a couple of hours, maybe 2, 3 hours, it starts detecting the temperature and the humidity. I don't know how, but that's how the low cost sensors are. So, any which ways, guys, I thought, it'll be good to show you how things works. So I hope you understand the entire logic of DHT11 sensor. What we will do is, in order to detect the temperature properly, we should actually replace this DHT11 with DHT22. I don't have the sensor right now, but I'll be getting it in probably 2, 3 days. DHT22 is more stable. There are also more advanced humidity and temperature sensors, which is little bit of expensive, not much, probably about 600, 700 rupees. That's pretty solid and rigid. For now, go ahead and try with DHT11. If it doesn't work, try DHT22. The library is same, code is same, so we just confirm that the code works, the library works, the OLED works, the circuit works. It's just that the temperature is not being detected from the sensor DHT11. Alright guys, so I hope you guys had fun. Do reach out to me if you have any questions. In the next lesson, I'm going to show you, using the same sensor, how to publish the data on the web. Whether the sensor is working or not, DHT11, main thing is our code and the architecture and the entire framework should work. Once that works, then you can just throw the sensor and plug the DHT22 or any other advanced temperature humidity sensor. It's going to detect and throw the information on the browser itself. So that's what is going to happen in the next lesson. Stay tuned. Goodbye.